Good morning or good afternoon, and welcome back to MoveTips. And today we're going to do 4 quick tips for curating data in Skyline quickly. So Skyline has a lot of really good visualization tools that help you to quickly see whether or not the data is of high quality and to look for areas where there may need to be a reintegration, for instance, of a peak. So what we're going to do this morning is do 4 tips that I like to use in order to quickly see if there's issues with your raw data in Skyline. So we'll just jump right into it. Number 1 is the page layout. So when you open Skyline, you might see something that looks like this, which is great for tabbing through chromatograms, but there's a lot more data you can see easily on the one screen. So what I like to do is to use a specific kind of layout that allows you to quickly see issues. So the first thing we're going to do is we're going to show all the peak areas. So we're going to go to View, Peak Areas, and Replicate Comparison. And what that does is generates a plot which you can dock, and I like to just dock it up in the top. This gives essentially all the peak areas for that particular measurement in every chromatogram. The second is the time view. So I want to look at view retention times and then replicate comparison. And if we put that, I like to dock it again, you can drag it, and I like to dock it on the right-hand side. That's going to show me very quickly across all of the replicates where there may have been, a peak that was integrated at a different time than the others. And so for this molecule, you could see right away there may be a couple that we want to address. The third sort of panel I like to bring up is my calibration curve if I have one. So in this case, we do have a calibration system. So I'm going to go to View, Calibration Curve, and I like to dock it kind of down on the right-hand side. Now in this case, it's going to show, it says that there's an error because I'm on the internal standards. If I were to go down and look at any of the molecules, you'll then see the calibration curve. So if you bring up this type of document and you're on an internal standard and you see this error, that's not really a problem. All it means is that you don't have a calibration for that particular molecule because it's an internal standard. Okay, so that's move tip number 2, or move tip number 1 is to sort of tip number 1 is to lay out these the grid so that you can see your peak areas, your retention times across the replicates quickly. Allows you to go, in this case, if we're right on this first molecule, you can see this molecule needs to be reintegrated, so it should be this one earlier retention time. We click on the molecule, we see that it's integrated something a little later. We can just click on it and reintegrate that peak. Okay, hopefully that you understand the layout. Curation tip number 2. Use the Synchronize Integration function. So while that run was easy and we only had one outlier, you may go down to something else like this that looks like it has maybe 4 or 5. If you have a whole plate of samples, this is a small sample set. If you had a whole plate of samples, it may take you a lot longer to kind of click through each one of these. So what I like to do, once you know that your chromatography is stable, if you click on one and you decide, okay, this is the peak that it needs to be, you right-click and then turn on Synchronize Integration. What this is going to do is for every either replicate, you can also do it by groups or sample type, but for every replicate that's selected, it's going to assign the same peak once you click on it. So if I go over here now to the peak that's incorrectly assigned and then assign the correct peak, what it's then going to do is correct all of the assignments to that peak. So now if I go through all of the runs using my fancy control down arrow key and kind of panning through a bunch more replicates, you can see now that that same peak is integrated across all the runs. Okay, so tip 2, right-click, Synchronize Integration to allow you to synchronize things quickly across all of the runs. Tip number 3, ion ratio view. So in this case, you have let's go down to this molecule. We've got 3 molecules that have the same mass, and there's 3 isomers. We've got some integration issues across the top. One of the nice ways to use this top left view where we've got all of the ions is to right-click and click on Normalize to Total. All right, so the third tip is use the ion ratio, sort of the ion ratio view in here. What this does is it normalizes all of the product ions within that run to 100% of the total intensity. And so you can more easily see where there may be an outlier, in this case, where the ion ratios for these are a little bit off. And so this sort of especially helpful when you're looking at complex MSMS spectra, like from peptides or from other small molecules that have a lot of fragments. In this case, I will highlight, however, that when we talk about using MSMS to identify small molecules, I will just let you be the judge of whether or not it's easier to see the outlier in this ion ratio molecule view or the outlier in the retention time view. Clearly, my opinion is that it's easier to see these outliers, and so it's good to have both. So we're going to click here, and then we're going to go back to this peak that to correct that integration across all of the peaks. Okay, so that's 3, the ion ratio view. I'm going to go back to the main view to show this last one. Okay, so the last point the last tip is to kind of group these molecules. You'll notice that in this case we ran a calibration series, some QCs at the beginning and end, and we ran pools throughout. If we go down to one of our molecules that is being quantified, one of the things that makes it easier to kind of see if things look reproducible is sort of 2 steps. First, maybe we want to group some of our molecules together. So I want to use the edit, manage results, and then I'm going to put all of my blanks, so I'm just holding down the control key, I'm going to put all of my blanks together and shift them up. Then I'm going to put all of my calibration samples together. Then I'm going to put my low QCs together, my high QCs together, and maybe I want to put my study pools together. You can continue this on down for the whole data set. But what you'll see is that this now reorders the default display. Looks like we may have a little bit of variability in this case. What we want to do is right-click and say normalize to heavy. And so what this does is it now puts all of the molecule replicates together that are of the same sample type. So if you want to look and see what your comparative performance is for sort of individual preparation replicates or biological replicates or technical replicates, you can kind of group those together. So quick sort of run through of those four curation tips again. First, organize all of your panes so you've got sort of view of your peak areas, your replicates, and your calibration curves all on one view with your chromatograms. Second, utilize the Synchronize Integration tool where you can turn this on and automatically synchronize the integration for all of your molecules at one time. Third, use the ion ratio view. So this, in this case, is this right-click and then normalize to total. That will turn the ion ratio view on for looking at the relative contribution of MSMS. And then fourth, group the runs together by using edit and manage results, and then grouping the molecules in any way you want to in the view. One thing I'll say about this last one, if you want to view the data in a way in which they were collected, you can simply go back to order and turn this back to acquired time, and it will it'll just reorder the data back to the way that they were acquired, so you can quickly kind of pivot back and forth between the sort of ordered by sample group and then ordered by acquired time. Okay, that's a little bit longer one today, but appreciate everybody joining, and until next time, thanks again. Bye.